Hello everyone, I'm Xiaogang. Okay, we've set up this framework for you, but this framework shouldn't be something I need to teach you. You should already be familiar with it in Blueprint. You might not have written much C++, but you should have written all of this in Blueprint, right? So what do we need to do now? Now we need to start creating some classes. And for convenience, to avoid having to keep refreshing this header file during the project, which is annoying, I just take the digs and directly create them in. Although it looks a bit messy, it saves trouble. Yes, it saves trouble. This makes it convenient. This way, I avoid having to keep refreshing the project for you. It saves everyone some time. Okay. I'm going to create this many things. But don't rush just yet. You can skip it for now. It's fine. Okay. Good. So we'll stuff it in here. And then I think the character part should be fine. We don't have the UI yet, but this damage actors pi. There might be more later. We'll just stuff it in. We'll spend a few dozen seconds handling it. I was about to make it really complicated. And then this, there should be some more things in the feedback. Let's paste it. Okay. Then, hit the ones in the UI. Yeah, as for the UI, let's take a look. There should be a damage. The damage will be used later, because when using damage, actually we also have a shell here, okay? Alright, let's just paste this much for now. Then when we move to the next stage, we'll paste the files again. This won't affect your compilation, because they are all txt files. It is actually written like this, purely for my convenience in renaming. This thing, if you configure something like this in this txt file, it might not be packaged. You need to be careful. Don't write it like I did. Okay. Let's close it first. Alright, so first we need to use gas. Right, then we definitely need a component. So we need to create a component. As for this component, we need to place it in this position. Put it into our AVDSYST. Because GS actually has a lot of things that can be written. That can be rewritten. Okay, sorry. Need to refresh this side. So the first component we create, we'll put it in this place. If you've ever looked at a Lyra business structure, you'll find that it rewrites everything inside the entire GS. We won't rewrite that much. We'll only rewrite what we need. Okay, here we'll create an AbilitySystemComponent. This component, it is a component of our GS. Okay, this component it is used to manage our skill activation. This series of things. Then here, we need to include the header file. Okay. Well, we don't need to write anything for now. Don't write anything. Because before we officially write the code, we just need to create this class first. Then we create its C++ source file here. Okay, and at this point, we can see. Okay, this should be no problem. Let's compile it now. And it must pass compilation, okay? Obviously, we are missing a semicolon here. Let's just compile it again. Good. Now we have passed the compilation. If the compilation passes, here we will first take a look at the comments in the source code. You can check your notes yourselves. This is our core component. That is our GS. You can see how many lines of code it has. Just the header file, you can see. The header file alone has 2,000 lines, and this is just one file. You can see that the entire GS is very complex. Okay, my suggestion is that you first learn how to use it, and then you go ahead and just follow my usage first, after you know how to use it. Then you'll think about what features you need. What kind of functionality GS provides you. This is a relatively good, reasonable way to learn. Okay, alright, so now we have created this component. Inside the component, we need to not do anything. Then at this point, we go to our character section. Go to the character section. We need to instantiate this component. This is the GAS component. It can be attached to many places. It can be attached to player state. You can attach it to the character. We choose to attach it to the character. The main reason for this is It is relatively simple and easy to implement because all our AI and player-controlled characters need this capability. In a narrow sense, it only defines game skills. In a broad sense, it can define all game behaviors. For example, game start, game end. All sending messages can all be defined. In a narrow sense, you can only define this kind of fireball, melee, attack, ranged attack, investment, and things like that, or skills like potions. But in reality, you can define many skills. So first of all, let's come to this character base here, because we need to add this component on the machine, right? I personally like to put these components at the very bottom, because you like the engine, sometimes it likes to put components at the very top. I like to put them at the very bottom, because these are all special protection or such a variable. Then here we create a pointer to this GS component for the name of this place. We need to forward declare it. We should not directly include it here. As for the related information here, let's just call it GS here. Do I need to explain these red marks here? This is blueprint readable, and it can be seen from anywhere. And the category is this category. As for its meta, it means allowing access to its private variables. So once we have such a method, we need to prepare a method so that it can retrieve our GS component since it is protected. So here, at the very front here, we write a method to get this component. And actually, for this method, they can write it like this, because Unreal Engine prefers this style, both in line. This will be written like this, and then here we can do it this way. And then just return this thing. It should be returning it. Okay, we need a semicolon here. Right. If you declare it like this, you'll have to move this part over here for it to work. That's the correct way. Okay, let's format it. It should definitely compile now. But there's still a problem, because this is just a pointer. You haven't actually instantiated the object yet, right? Let's compile it first, then we'll continue writing the rest to avoid any issues. Okay, no problem. Then in the constructor, we need to continue writing. First of all, we will take this tick, turn it off, because sometimes we might not need this tick. So we turn it off. Okay, then next we go to create such a component. So you can just create it directly like this. Then here we need to include the header file should be, as for this header file, since we have already handled the paths, we can directly include the header file like this. Okay, after creating it, it definitely needs to enable network synchronization. So we enable network synchronization. Then here we set this synchronization mode, this model to max. And then his different modes. It depends on some information it synchronizes if you are playing offline. If you choose max, it is actually a form of mixed synchronization. The specific information it needs to synchronize, that is, it only synchronizes this minimal gameplay effect. We call it the wingy pilot effect onto this magic pointer. But for the player and the host proxy, it will fully synchronize. As for mellow, it only synchronizes this effect, this info. So we generally just use max. For us, clicking will use negative. Right. These are the three modes. These three modes of GS. Obviously, the more synchronization there is, the greater the consumption. But we don't need it for single player. Right. Okay. So we are done with the spot, and sometimes we need to modify our update frequency. This update frequency, this parameter, it is within the actor. It will depend on our actor, how many sync updates it performs per second. Let's make it faster. Set it to 100, because if the sync frequency is too low, it will affect the actual experience of your GAS. If you place this GAS component on our player state, you need to know that player state, it only syncs some player state information. This player state is not the player's PUN. It's things like the player's goal information or some other information. Then its sync frequency will be too low, which will cause problems. So sometimes you need to modify the sync frequency. Okay, after writing it like this, we still need to continue writing some other things. We need to write a method here This method is mainly to make it convenient for us to get our player's controller. Let's see if we can forward declare this controller here. Because this is a base class, once we write this method here, all of our subclasses can use this method. And this method is also exposed to Blueprint. So it is actually very convenient. So how is this method implemented? It is actually quite simple. As for its implementation method, we can just implement it directly here. Okay, good. So there should be no problem. Good. You can see that if we compile, it will report an error at this point. So we won't write it this way. We just won't write this explicit class point. We'll just have it implemented in the original file because it might need a conversion here. We'll write it this way. Okay, because it prompts you here, but it doesn't include this. Then we include its header file here. This might be more troublesome because we are using the most native version of VS. Every time you need to reference related classes, it will often prompt you that the header file is not included. Okay, so at this point, you can see that it compiles successfully. Okay, since we wrote this, let's also write player stay because sometimes we might need to use it. Okay, and for player stay, we can do it like this. If you use this, it will report an error. That is, it will crash. That is, if the conversion is not successful, it will crash. This is very good because it makes it easier for us to troubleshoot errors. Because what kind of error to check? Because you might be on the AI's PAM to get the player controller. Then this thing might have a relatively serious logic error, so we give it a crash here. This way we can clearly know when we code this method. Okay, so actually after writing this, we truly need to write this whole series of things. Now let me explain what this series is. This is the interface of the ability system. As for this interface, you mainly need to implement this interface. This way it can more accurately perceive the existence of this ASC. This is game queue. We call it game queue. It's not that we like to call it GC, but its GC is not garbage collected, not garbage collection. Dynamic queue specifically handles effects. This is the Astino interface of game pay tag. We covered this in the previous lesson. It is specifically used when handling game p tag, such a thing. So we have 3 interfaces. Then for these 3 interfaces, we definitely need to include them. We make a hierarchical distinction after including these 3 interfaces. Then we can click on this interface. As you can see, this part is C++. It must be implemented. So now let's implement it. As for this implementation, actually, we can take a look. It's quite simple. We can just copy it directly here. You see, we put it below. Then we remove this 0. We create its implementation. We can just use this return directly here because it can be upcast here. It's clearly possible to upcast. Okay. Then regarding this game queue, we can ignore it. We just leave it hanging here. Don't worry about it for now because this course hasn't covered it yet. Okay, mainly regarding these gameplay tags, we need to handle them. Let's open gameplay tag. We mainly see there are several methods here. These methods are it. We need to get a container for this Cambler tag so that it's convenient for us to query and manage. So it's mainly these 4 methods. We need to do a simple processing on them. In this place, you just need to copy these 4 methods over. We'll just put them at the bottom. You can see, as for the access level of these 4 methods, they should all be protected levelly. As for this class, it should be an interface. It's hard to say about this access level. Because this part might be a bit strange. Oh, this access level, because you're not sure, it might have that will bring a public thing, because we explained it to him before. This T, using the uClass body thing to replace it. We need to check the underlying layer to know this, but this doesn't affect us. We'll just set it to public. It doesn't really matter, because even if we expand this level, it's fine. It's just about the protection permission issue. There might be a small problem here. Okay. So we have created these few methods. As for these methods, how do we implement them? Actually, for the first method, it gets this container. We just need to pass this ability system to such a container. Because it's a reference, we can handle it this way. As for this tag jack, we can also directly process it through our ASC. Correspondingly, we generally only do one layer of slash forwarding, right? And if you look closely, you will find these methods are all the same. Is it possible that this ability system implements a related interface for these? Right, you essentially just doing forward because it has already been implemented for you. You should be able to get my point here. You can see this method and this method are exactly the same. We have it here. We let the ASC handle this. Okay, so basically at this point we have actually already simply created this ASC. Alright, so let's stop here for now. We have created the ASC and materialized it on site. Then also forwarded its tag in association with our interface.